Hi viewers, welcome to World of CNC. This is slide number 14. In this we will discuss the turning process using Mastercam software, and the profile will be like this. We have different diameters and different lengths. The maximum diameter of the finished component is 30 mm, maximum length is 75. The raw material size is dia 32 by 90, 32 mm diameter, 90 mm length. This is the raw material size. We have different points on the profile. We have different coordinate values for each and every point. We have to start the profile with 0, 0 and we have to complete it with 0, minus 75. That is the 16th point. Okay, 1 to 16. We have to plot the coordinate values, and we have some important steps before creating the profile. Go to planes, selecting lathe diameter D plus and Z plus. Say whatever may be the diameter, directly we can input. Otherwise we have to follow the radial programming. We have to give half of the value for X always. So there will be a little bit confusion, so better to follow diametrical programming and write down the sequence of operations, what are the operations we covered in this profile, that we have to list out. Selecting the tool paths for different operations and applying suitable parameters. Finally go with the simulation and generating the NC codings. These are all the steps to be followed. First of all, we will see the coordinate values. This is 0, 0 and this one is the minimum diameter on the profile, 8, 0. Here it is C2 into 45 given, the chamfering value. C2 means this chamfering distance will be 2 mm, this horizontal distance. If it is a 45 degree, this small height also the same. Okay, this is 2 mm and this height also 2 mm, top side 2 mm and bottom side 2 mm, totally 4 mm we have to reduce from this major diameter of 12, we will get this minimum diameter of 8, so that the value will be 8, 0. This is the point 12, minus 2. Minus 2 means this distance will be 2 mm. We are following the absolute programming. From this reference point, we are giving all the Z values. Okay. And this is the point 12, minus 15, 8, minus 15, 8, minus 20, 12, minus 20. This is 20, minus 25. The length is 25 here. Okay. 20, minus 35. The diameter is 15 here. 15, minus 35. No change in X value. Sorry, Z value. Here. 15, minus 45, 20, minus 45, 20, minus 55. This point will be 30, minus 60. Here the radius is given as 5 mm. This is 55 mm length, and whatever may be the radius, this distance also the same, so that we are getting minus 60 here. This is the last point. 30, minus 75, and we have to complete the profile with the axis once again 0, minus 75, so that start with 0, 0 and complete with 0, minus 75. Simply we are going to plot the points while creating the sketch. Now we will see the profile. See, finally we will get the profile like this after simulation. Okay, now we will see the software. This is the Mastercam software version X6. Initially the icons will be scattered like this. It is not in the uniform order. Okay, we have to arrange it. The very first step will be go to settings. We have to set the unit. Go to settings, go to configuration, select metric input. Here we have two options, one is English and another one is metric. Select a metric input, That means we are following the metric input only. We can see at the right bottom corner of the screen. If it is inches, we can go with English, no problem. Second step will be pressing F9, so that we will get this cross hairline. We will get 4 quadrants, first, second, third, fourth. For lathe profile, we have to create the diagram in the second quadrant only, so that X value will be plus, Z value will be minus, the negative value. And the third step will be arranging the icons. Here some icons are missing. It is scattered like this. Keep the mouse the empty area of the icon bar, right click and go with the last option, load toolbar state. Keep the mouse nearby. We will get a 2D toolpath, 3D toolpath, like that. Now we are creating the profile two-dimensionally, so go with the 2D toolpaths. If it is a 3D, we can go with the 3D toolpath. Now these icons are arranged. The next step will be go to planes. Already we discussed. We have to select a D plus and Z plus, whatever may be the diameter, directly we can input. So that go to planes, selecting lathe diameter D plus and Z plus. That option will be coming here. We can see. Now go to line command. Select line command, create line endpoint. This is already selected multi-line option. This we have to select continuously. We can plot the points. Now we can plot the points starting with 0, 0, 0, 0, 8, 0, 12, minus 2, 12, minus 15, 8, minus 15, 8, minus 20, 12, minus 20. Say one grooving is completed now. We have one slanting line, 20, minus 25, 20, minus 35. One more groove we have, 15, minus 35, 15, minus 45, 20, minus 45. Two groovings completed. We have one horizontal line here, 20, minus 55. We have a slanting line here for creating arc. The next point will be 15 or 30, minus 60, 30, minus 75, 0, minus 75. The last point will be 0, minus 75. Now we are completing this profile. Almost completed except one arc. For creating arc, go with circle option, create arc endpoints to be selected. Simply select the starting and end point. Click at 2 points. Give enter. Go with arc endpoints 1, 2, first point, second point, escape. Say we have done a mistake here. We just remove that arc. Go with arc endpoints. Here starting point, end point, and then we have to enter the radius or diameter here. Then only we will get 2 circles. The radius will be 5 mm. Enter. Now we are getting 2 circles. say according to our profile, which type of arc we need, that we have to select this type of arc only. Go with software and click on the particular arc. The other lines will be deleted and then give OK. Now we have to delete this unwanted line. Click on the line, select the delete button, the line will be deleted. Now we are getting the profile 100%. Now we have to select the machine, we have to select the toolpaths and applying the parameters. Before that, we need to select Alt plus O. We will get Operation Manager window page here. Already one machine group is selected. How to select this machine group means, go with first we have to remove this. Defaultly it is selected. Say we have 5 options. Go with the machine type, milling, lathe, wire cut EDM, router and design. This is 100% lathe oriented operation, and go with the lathe default. Suppose we want to generate the codings for a particular controller, we have to go with the manage list option. There we can select a particular controller from the library. Now we don't have the other controllers. Fanuc only we have. Go with the default option. We are getting machine group 1 and open this property. Click on files. These same 4 pages will be appearing here also. Page wise we have to click output machine name to NC. Finally we are generating the codings. For that we need to select and go to tool settings. This is nothing but a program ID, and right side 2 options we have to select tool path configuration. The first one is we have to arrange the operational sequence. First operation is what, second one is what, third one is what, like that we have to arrange in sequence. The second option will be one of duplicate tool numbers. Suppose we forgot to select a proper tool for proper operation. First we are completing the facing and rough turning cycle. We have to select one more tool for finishing cycle. Unfortunately we forgot to select. That time the machine will indicate immediately you have selected wrong tool. So you have to select the proper tool, like that. For that purpose we have to select this option and go with the advanced option, all the 3 to be selected. Automatically the machine will calculate this clearance height, retraction, feed plane, and go with the adjust on feed arc. We have different diameters in our profile. According to variation in diameter, the spindle speed will be varying automatically. Automatically we will get a better finish on the surface of the workpiece. The minimum diameter, the speed will be more. Maximum diameter, the speed will be less, so that we will get better finish. And this one is a feed calculation. Actual machining, sometimes we will take from tool or from material. Okay, for simulation purpose, anyone we can select now. This is material selection. Aluminum 2024 already selected. If you want to change, you go with the select option, open lathe library, n number of materials arranged. We can select any one of the material here, like aluminum 7075. Just click there, that material will be coming here. And this one is a cycle number. If you change it to 10, first line starts with N10, the second line incrementally 10, N20, N30, like that. So that if you want, we can change and go with the third page, stock setup. The first one will be raw material size, second one is jaws setup, third one is for tail stock purpose. Suppose we have the lengthy bar stock, we have to hold the workpiece by using the tail stock. Here we have 75 mm or 90 mm length only, no need for this property. Go with the first property. Select make from 2 points. You just click at 2 points 0,0 and the maximum diameter, we will get the exact value of this profile 30 and 75. Directly we can increase the raw material size here itself. Instead of 30, 32 we can give. Instead of 75, 90 mm extra length we can give. This is for facing allowance 1 mm. Directly we can input, or otherwise use margins option. If we select this one, separately it will ask diametrically how much mm extra we need, and right side facing allowance how much we need, left side for holding purpose how much we need. That separately we can input and give OK. Go to second property. This is jaw position. Say this type of jaw we need. Say we have different types. This is suitable for our component. Left side we are holding the workpiece by using the jaw. It may be 3 jaw or 4 jaw. Okay. Select the first one and go with the from stock. Here it is asking, say extra 15 mm we have given lengthwise. Instead of 75, 90 mm we have given the value. In that 15 mm, how much length we need for holding purpose. If we give 10 mm, 10 mm will be inside the chuck. The rest 5 mm will be outside. That 5 mm will be the clearance between the finished component and the chuck. Okay. Simply give OK. Now 2 parameters are OK. 2 properties. This is no need. Directly give OK. Now we are getting the profile like this. Say this is the jaw, and inside this is nothing but a finished component profile, and this is nothing but the cylindrical piece, raw material. Now we have to select the tool paths. Go with the tool path. First one is the facing operation. Go with the face. We can give the name here itself. Facing, like facing. Like that. Give OK. We have to select the tool. Say we have n number of tools. This is having most nose radius 0.8. For rough turning cycle 0.8 or 1.2 we can use. For finished turning cycle like this 0.2 or 0.4. The tool will be, just to see the tool tip. Compare this tool tip. This is suitable for finishing operation. This is for rough turning cycle and facing. Okay, now we go with this tool. First page, for project purpose we can change the parameters. What is the speed we need, spindle speed, feed rate. Sometimes we will use a coolant also. That time we can use a flood type or mist type. For simulation purpose no need, simply give OK and select a tool. Go to second page directly. This is entry amount. Initially the tool is 2 mm above the work surface. That is the meaning. If you want we can change it to 5 mm also for safety precaution. Now we have 2 parameters, rough step over and finish step over. For facing operation roughly we can take. No need for finishing cycle. Remove that and select a rough step over. If we give 0.5 here, say already 1 mm facing allowance we have given for Z value. If we give 0.5 here, first 0.5 it will remove and then one more 0.5 it will be removed. Okay, so 2 passes will be there. That is rough step over. If we want finishing also, here we can give 0.4. That means here 0.2 will come. 0.4, 0.4 2 times. The rest 0.2 will be a finishing cut, so that 3 passes will be there. No need. Only rough only we have. Give 0.5 and overcut. What is that overcut? Already we discussed. Say instead of stopping the tool exactly at x0, z0, due to the nose radius of the tool, small protrusion will be formed here at the middle. To avoid that, we can extend the tool limit up to x minus 1 in the CNC programming. The same procedure. Here the term will be the different one, overcut amount. 1 mm we are extending the tool limit. That is the meaning. Simply give OK. Now facing operation has been completed. Before starting the rough turning cycle, we have to remove these lines. How to remove this? Go with the toggle display, the lines will be removed. Now we can select the next operation, rough turning cycle. Here this line is not connected, it is a partial one. So that we go with the partial chain and select near the starting point and near the end point. Now starting point and end point both are selected. This complete contour we are turning, that is the meaning. The starting color will be green, end point will be the red, and then give OK, applying the parameters. Before that select a tool, the same tool we can select now, go with rough parameters. Here it is asking how much depth of cut we need. If we give 0.5, the tool will come down 0.5, 0.5, 0.5 every time. That is nothing but depth of cut. Already we left some stock of 0.2 on both axes. If you want, we can change the value. This is for a finishing cycle. Simply give OK. Now rough turning cycle is completed. We can see the lines. Every time 0.5, 0.5 it is coming down. Before finishing cycle, we need to remove the lines. We just go with toggle display, removing the lines, and go to tool path, select a finish turning cycle. The same procedure for this also. Select a partial and select the starting point and the end point and give OK. Now we have to select one more tool for finishing, this type of tool. Select that tool, select it and go to parameters. See already how much we left in the previous cycle, that we have to enter here, 0.2 mm. This is for finishing cycle in one pass. That is the meaning. Give OK. Now finishing cycle also completed. Go with the tool path once again. The next operation will be grooving. Say we have two groovings here on the profile. Before that we have to remove the lines. Go with the toggle display, remove the lines and go to tool path, select a grooving. Here we have some options, 1 point, 2 point, 3 lines like that. Better to select a 2-point selection. Say on the profile we have to select these 2 points. That is the meaning. That means top to bottom limit we can get, right to left limit also we will get. So that we are selecting 2-point selection, give OK, click at the same 2 locations here also. At a time we can select n number of groovings in Mastercam and then enter. Now select the tools. Any one of the tool we can select. Selecting the first tool, go to second page. First page no need to change. For project purpose we can change. Select. Say suppose we have this type of groove. We have to give some other parameters. Okay. We have 90-degree groove only. No need to change the values. Go with next page. Here already 0.2 stock we left. Say wall side as well as the floor side 2 mm, 0.2 mm we left. This should be removed the next process, that is a finishing cycle. Go with the finishing cycle. Enter that value 0.2 here. That means the 0.2 mm is the left out material will be removed in one pass. And then give OK. Now 2 groovings are completed. And then say that the error is coming. Why? Because the width of the tool we have to change. See, the width is different, So we have to select a minimum width of the cutter so that error is coming. Or otherwise, separately we can perform this operation. Sometimes we will get a correct one. If you want, we can remove this option. Go with delete. This groove only we deleted. Once again, go with the tool path. Select a groove. Select tool path, 2 point. Give OK. First, we are selecting the left side groove and then enter. We have to set the parameters. The last option only we have to change 0.2 mm. Give OK. Say one grooving completed. Remove that option and go with the tool path. Select a 2 point selection. Give OK. Now we can select these two corners and then enter. Select the same tool, same 0.2. Same tool we are using so that the value is not changed. Give OK. Okay, 2 groovings completed without any error. We have to remove the lines and the last operation will be the threading. Go with the threading. Select suitable tool. The cutting edge should be left side. This type of tool we can select. Okay. This is a right side cutting edge. Better to select a left side cutting edge. Go to second page. Here length of thread it is asking minus 17. Why? Because 15 mm is the threading length. Okay. So here it is 15 mm. 2 mm extra we can input. Already we have one groove left side, so that minus 17 we are giving, and then go to select from table. These parameters no need to change. Directly we will get the values from the library itself. Directly we can pick the value 12 into 1.5 as per the diagram. Select the value. Give OK. These parameters now we got. And go to the third page. Say the metric threading angle is 60 degree. Half of the angle it is asking. Enter the value as 30. And acceleration clearance. If we give 10, what will happen is from the reference point 10 mm away from the workpiece, the threading cycle will start. No need. Simply give 2 mm. Directly we can start with 0 point also. Already we have one chamfer. Anyhow, the threading cycle should be started with 2 mm away from the workpiece normally. So that 2 mm is there. Give OK. Threading cycle completed. Almost we have covered all the operations in this. Now we will see the simulation. Here only one operation has been selected. See the green tick mark. We have to select all the operations. For that, click here. Now all are selected. Regenerate the operations. Move the profile and go to verify option. If you want, we can keep the profile like this. It will be visible. Now we can do the simulation. If you want, we can reduce the simulation speed here itself. This is simulation icon. If you selected this one with the tool, we can see tool holder. This is the tool only. Start. First one is facing. Now it is performing the rough turning cycle. See here, we can see the tool insert only. If you want to see the tool holder, stop simulation. select a tool holder and then start. Now we can see the tool holder also. See, this is the way to do simulation using Mastercam software. If want, we can increase the speed. So once again we will start simulation. Okay. Finally, how to generate the codings? That is very important. Close it. Go to G1. After simulation, we have to select this. Already NC file and edit selected and give OK. Now it is asking where we want to save. Go to desktop or some other drive. Here we can give some name and give OK. The codings are generated automatically. If you want to see the codings, say this is a program number, operational wise. First one is spacing, rough turning cycle, finish turning cycle, all the operations are there. Say operational wise. This is the last one, threading cycle. Here we have the syntax G76. Simply we can compare this syntax with CNC programming. Okay. You just go through this video, understand the concept, take 2 or 3 profiles, practice, it will be better. So this is the final product. Okay, thank you all.